Well, welcome to Module 3 and our focus on climate change. What we're really trying to do overall throughout Module 3 is gain some scientific understanding about climate change. And we purposefully are focusing on the scientific language and the scientific concepts that explain climate change so that you can have an informed, be educated and informed about what climate change is, what is driving climate change. And we believe that that is sort of the key for you then to be able to go out and discuss with others what climate change is, go into businesses and companies and firms and have a strong understanding about climate change and what needs to happen in order to be make consistent changes. So really we're looking at helping you better be able to explain to others what climate change is, how we know climate change is happening, and the long-term negative effects of climate change, and what we need to do differently in order to avoid those long-term effects. So this first introductory lecture of 3.1 is more just giving you some of the basic information about why climate change is an urgent issue, one of the biggest crises that we need to be facing and focusing on right now as we struggle to maintain or attain sustainability within our civilization. From this particular lecture, there are three new terms that we will be introducing: climate trends, atmospheric carbon dioxide, and surface ocean carbon dioxide. So why focus on climate change? Well, first of all, climate change is, by the vast majority of our society globally, considered to be one of the most urgent environmental concerns that we face. Climate change is influencing and being influenced by all sectors of society. Those of you who are in the apparel and textiles industry, those of you who are in the interiors and buildings industry, know this. We talk about this in our other courses, how what we do in these businesses and industries influence climate change, but also how our business world as we know it is being changed by climate change. So as young professionals who are going to be entering into your respective professions and industries, you will have the opportunity to develop new ways of responding to climate change and being responsible in how you produce, manufacture, build, design, etc. Of the many environmental concerns that we face, climate change is definitely among the most urgent because we have set in motion a comprehensive change to our global climate that will impact multiple aspects of the biosphere. We are already observing things such as rising temperatures, rising sea levels, species adaptation and extinction, and increased frequency and severity of extreme weather events. These are all of the things that we're already observing and are the result of our changing climate. So together, these things that we're observing are going to change things like agriculture, how and where and what we can grow, access to water that's drinkable, safe to drink, that we have access to, and things like where and how we live. And so basically we focus on climate change because we have no choice. if we want to be able to answer this question of, are we as a civilization going to have a quality of life in 100 years that we currently enjoy, we can't expect that if we are not focusing on climate change. So in this course, we are going to talk a lot about how the driving force of climate change is the production of greenhouse gases, including carbon dioxide. And we are going to be discussing how human behaviors are the most significant contributors to greenhouse gases and carbon dioxide. This is a fairly political topic of discussion right now here in the United States. It was announced a few weeks ago that our president was going to be withdrawing our country's agreement within the Paris Agreement on climate change, and so it has been a hot topic lately. The assumption in this course that I base everything off of is that climate change is real, climate change is happening, and climate change is primarily being driven by human behaviors. We can certainly have discussions within our discussion forum about any of these issues, or if you want to email me or talk to me privately about any of them. But those are the assumptions that I go off of. And we will have a lecture, I think lecture 3.3 is providing everybody with what the scientific world's consensus on climate change and how I can confidently say it's happening, it's caused by increased carbon dioxide and other greenhouse gases, and humans are the chief cause of those. All right, so the next two slides are short YouTube videos of the effects of climate change, and then the second video is emerging patterns of climate change. So I would like you to pause the audio for a moment and then go ahead and watch the videos on both of the slides. Okay, so hopefully those videos were helpful in reminding you, sort of as a review of what the effects of climate change are on our globe and what are some of the current patterns of climate change, what's happening globally in terms of climate change. Scientists have been measuring and recording global temperatures for well over 100 years already. And there is an organization, an international organization called the Intergovernmental Panel on Climate Change, IPCC. This is a conglomeration of thousands of scientists from all over the globe who are working on climate change related research. And they review research, and they publish research related to climate change. And much of what we share in this class related to climate change comes from IPCC, Intergovernmental Panel on Climate Change. And this figure that I have on this particular slide comes from IPCC. And what it's showing you is globally average combined land and ocean, surface ocean temperatures from 1850 to 2012 from 3 different data sets. So not just relying on one data set of measuring of temperatures, but taking 3 different data sets, averaging those 3 data sets, and then tracking what has and also measuring land temperatures and surface ocean temperatures. And you can see it goes back to 1850 all the way through 2012. The graph uses, as I've said, average temperature in Celsius. And it's important to know that this is based on observed data, so measured, collected data, not on predictions. And it was so what we have right here, there's this red line. This is the standard temperature that was calculated during a period of 30 years. It's this red horizontal line on the graph. This is after warming trends were already being observed. And so scientists said we should get some baseline data. And that is when we start, after that is when we start to see temperatures start to increase a little bit more drastically. Also, for reference purposes, please note that Celsius increments are smaller than Fahrenheit increments. So every 0.6 increase in Celsius is about 1.08 increases in Fahrenheit, for those of you who aren't as familiar with Fahrenheit. Earth's surface temperature in the year 2016 was the warmest we have seen since modern record keeping began in 1880. This is according to independent analysis by NASA and NOAA. NOAA is the National Oceanic and Atmospheric Administration. NASA and NOAA are two of the largest in the United States collectors of data related to climate change. So globally average temperatures in the year 2016 were 1.78 degrees Fahrenheit, about 0.99 degrees Celsius, warmer than the mid-20th century mean. So since 1950 to 2016, our global average temperatures have increased by almost 1 degree Celsius, 1.78 degrees Fahrenheit. This made 2016 the third year in a row to set a new record for global average surface temperatures. So we first were able to say that 2014 was the warmest year on record. We then said that for 2015, and then we said it again for 2016. So the planet's average surface temperature has risen about 2 degrees Fahrenheit since the late 19th century. This is a change that's been driven largely by increased carbon dioxide and other human-made emissions into the atmosphere. Most of the warming that we have seen has occurred in the last 35 years, with 16 of the 17 warmest years on record occurring since the year 2001. Not only was 2016 the warmest year on record, but 8 of the 12 months in 2016, January through September, with the exception of June, were the warmest on record for those respective months. October, November, and December were the second of 2016 were the second warmest of those months on record. In all three cases, only 2015 was warmer. So October, November, December of 2016 were not as warm as 2015, but 2015 set the record. Some other trends that we're seeing. So the first major trend we've seen is increases in average global temperatures. Other trends that we're seeing is increase in atmospheric carbon dioxide. Atmospheric carbon dioxide is obviously the carbon dioxide gas that is in our atmosphere. You can see that since 1950, we have seen a steady increase. Atmospheric carbon dioxide is measured in parts per million, which is just a way of measuring gas. And you can see that it has increased all the way since the 1950s. In 2015, we actually exceeded 400 parts per million of atmospheric carbon dioxide as a monthly average, which scientists said was a tipping point. Once we reached 400 parts per million, we were entering a realm of urgency. Another way that we have to measure how much carbon dioxide that we have in the atmosphere, that we have within our ecosystem, is through how much carbon dioxide there is in the ocean. So in conjunction with atmospheric carbon dioxide, our oceans hold a lot of carbon dioxide. And actually, 1/4 of all carbon dioxide emissions are absorbed by our oceans. So the more carbon dioxide we emit into the air, the more our oceans have to try to absorb. Unfortunately, the more carbon dioxide that we have in our ocean, the lower our pH values of the water become. So our oceans become more acidic. And of course, we've heard stories about how acidification of our oceans is problematic because when your ocean waters become more acidic, your water has fewer carbonate ions that are available for all of your marine organisms, oysters, clams, corals, plankton. Those marine animals use calcium carbonate to build skeletons and shells and to support their life systems. And when we have more acid in our water, when our water is more acidic, those calcium carbonates are not available. So we are basically, as our surface ocean carbon dioxide increases and our pH decreases. So if you look at the figure here that is provided by IPCC, the blue lines are ocean CO2. The green lines are pH. You can see one goes up, the other goes down. This changes the chemistry of our ocean and puts our oceans and marine ecosystems at great risk. So here is another video that I would like you to pause the audio for and go to the link and watch this. It provides a summary of the key issues related to climate change and describes how we could actually change our future by investing in and implementing solutions now. And then one last video that I would like you to watch before you wrap up this lecture. And this is again just some more information about what is climate change, what evidence do we have that it's occurring, why we should be concerned about it.